In this example, we're going to graph a parabola. There's several ways we can do that. The very first way we usually teach you how to graph a parabola is to pick some x's, plug them in to your equation, and get the y value, so you have your input and your output, and then you would plot all those points. Problem with just doing this method is you have to really figure out where the maximum or minimum point is, which is called the vertex. And it can be more difficult to find when you're just making a table randomly. So this method we're about to use is to find the x-intercepts, average them, and then we can get the vertex from that point. We can also graph parabolas by shifting, but we're going to focus on the x-intercepts in this example. So we have this equation, y equals x squared plus x minus 12. So we're going to factor it to find those x-intercepts. This one is easily factorable. If you couldn't factor it, you could put it into your quadratic equation, and you could do the same thing. You're just going to have some decimals. Not that big of a deal, because when we're actually graphing this by hand, we're just looking for a sketch of the graph. So when I factor this, I want to look at the sum, which is negative 12, that c term, that constant term, and then the product. The product is negative 12, which is that constant, that last c term. And the sum is that middle term, the x term, which is 1 in this case. So what two numbers multiply to get negative 12 and add to get 1? And that is 4 and negative 3. So now we're going to use those factors and write them. Set our equation equal to 0. So y is going to be equal to 0. We'll use our zero product property after that. So we're going to write 0 equals x plus 4 times x minus 3. My zero product property says that either one of those has to equal 0 for them to multiply out to get 0. So we're going to have 0 equals x plus 4 and 0 equals x minus 3. So I'll subtract 4 from both sides in the first equation, add 3 to both sides in the second. So I get these values, x equals negative 4 and x equals 3. Well, those are my x-intercepts. They're also called the solutions of the parabola, and sometimes you'll hear them be called the zeros of the parabola. So we can plot those. Since they're x-intercepts, they go on the x-axis. So we're going to go ahead and put a negative 4 and positive 3 onto our graph to start with. And now we're going to use those 2 points to find our our vertex. We use those 2 points to find our vertex. Now, our vertex is the point that's directly in the middle of that parabola. It lands on the axis of symmetry. And the axis of symmetry is the line that cuts that parabola in half. And if I picked any 2 symmetrical points on my parabola and I averaged the x coordinates of those points, the x value would be the x value of the axis of symmetry. And that's a vertical line. If you think about it, it's the same x value all along that line, because every vertical line has the equation of x equals some number value. So our vertex is always going to have that x value of the axis of symmetry. So you can use any 2 symmetrical points, but we're going to focus on the x-intercepts because those are usually the points that we find and can find easily. So in order to get what that vertex is, you just take them and you average them. It's the midpoint formula, really. Remember, finding midpoint is just finding an average of those 2 x values. So our x-intercepts, again, were negative 4 plus and 3, so we'll add them, divide by 2, and that gives us negative 1/2. Now we can take that's going to be our x coordinate of our vertex, and plug it into our equation, y equals x squared plus x minus 12. And that will give us what our y value is for the vertex. And I'm going to go ahead and convert the negative 1/2 to negative 0.5. It's just easier to put in your calculator. You can leave it as fraction, or you can turn it into a decimal. When I do that, I get negative 12.25. So I have my x value as negative 1/2 of my vertex. My y value is negative 12.25. And so now I can plot that point along with the 2 points I plotted in the last slide for my x-intercepts 3 and negative 4. So we're going to put that on the graph. There's 3, there's negative 4, and then down below we have our vertex, negative 1/2, negative 12.25. Then you can see we just put our curves through the x-intercepts, and then they come to a point at the vertex. And notice they're not straight lines. If you put straight line, then you've graphed an absolute value equation. So this parabola has to have a curve to it, so it's like a combination of a u and a v. That's it for graphing a parabola. Thank you for watching.